So welcome to 3.4, which is division with fractions. Caution, we are now ready for division of fractions. And I put that caution sign in front of the sentence because most teachers cannot give a good explanation for why dividing by a fraction is equivalent to multiplying by the reciprocal. Now let's explore an example. Recall from the definition of division that one number divided by another number can be thought of as taking 1/nth of the number. In other words, and here's an example, 8 divided by 4 is the same as 1/4 times 8, which equals 2. The quotient, which is the answer, can be interpreted in two different ways. If you just divide them, given the size of each part, right? Divide $8 equally among 4 people. You get $2 per person. Or the number of groups of size n that we can take from n. For example, 1/4 of 8 means 1/4 times 8, which is 2. So I can take 2 groups. So we're going to switch to doing 320.28a. So here's our first example, 3.28a. And actually this goes into, it's a very simple problem, but the answer is not so simple until you see it. So we have 10 adults. We want to know how many pairs of 2 adults per pair we can make. So we have 10 adults, and we're dividing this by 2 adults per pair. And so the answer is obviously 5. But let's look at what the answer is in terms of units. And here are the units. So we have adults divided by adults per pair. Now what I'm going to do is sort of jump ahead a little bit in this section, although we've already mentioned it, that the way to divide a fraction is to invert and multiply. So it's the same thing, adults divided by adults per pair, or adults times pairs per adult. These are synonymous. So in this one, the bottom one, the adults would cancel, just like if you did 6 times 2/3, you could get 4. Or even better, how about 7 times 2/7 is actually 2. In the same way, adults divided by adults per pair is pairs. So you get 5 pairs. Okay, so it says a jeweler's planning on making gold earrings. Each pair of gold earrings will have 2/21 of an ounce of gold. If the jeweler has 2/3 of an ounce of gold, how many pairs of earrings can she make? Divide by finding a common denominator and show the results on a number line. And so here's the number line. So we have 2/3, and we're going to divide that into 2/21. And we're going to do it by finding a common denominator. So we need to take thirds and turn those into 21s. So that we do that by multiplying by the form of 1, 7/7, I get 14/21s. So now I'm going to write this out the long way. I have 14/21s divided by 2 21s. The 21s cancel. I'm left with 14 over 2, which is 7. So I can make 7 pairs of earrings with the gold that is in 2/3 of an ounce. So let's do that on the number line. Here's our number line cut into 21s. And I have, the gold I have is 14 21s, which is right here. So that's how much gold I have. Now I'm going to cut these into 2 21s. And each 221 is 1 pair of earrings. So there's 1, 2, 3, 4, 5, 6, 7 pairs of earrings using the number line. Notice how the 21s cancel, right? Just like numbers do. Okay, so here it says a fresh restaurant prepares their béarnaise sauce ahead of the evening dinner rush. Each batch will serve about 10 patrons. The sauce requires 3/8 of a cup of dry white wine. If the restaurant has about 3 1/4 cups of wine available, how many batches of béarnaise sauce can they make? So here is the question that you need to answer. Will our answer be greater than or less than 3 1/4? And if you answered greater than, excellent. But here's the problem a lot of students have. So this is just 3 1/4 divided by 3/8. A lot of students think that when you divide, the result or the answer is smaller because of your dividing. But here's the key, right? And we've been over this. When you divide by a number less than 1, the quotient or the answer will be larger than the original number. It's just the opposite with multiplication. But I'm going to do this problem by finding a common denominator. So I'm going to change this one, this mixed number, into 13/4. And then I'm going to multiply it by 2 over 2 and get 26/8. So now I'm going to write this out with the eighths as the unit. So I get 26/8 divided by 3/8. The eighths cancel. And I get 26 divided by 3, which is 8 2/3 batches. So let's do this on a number line. So I build in the eighths here. 3 1/4 cups is the same as 26/8 cups, right? And I just put in every cup 8/8 in 1 cup, 16/8 in 2 cups, etc. So the batches, I'm going to get a batch every 3/8, which is up here. So I go 3/8, I get 1 batch. I go 6/8, I get 2 batches. I go, that's a 3/8, 1 batch. 6/8 is 2 batches. 9/8 is 3 batches. 12/8 is 4 batches. 15/8 is 5 batches. 18/8 is 6 batches. 21/8 is 7 batches. 24/8 right here is 8 batches, and then I get 2/3 left over. So here's a thought question. Could you justify the following rule for improper fractions using number lines for 4 2/3? So here's the rule. 4 2/3, of course, would be 4 plus 2/3. And they're saying the rule is you can just multiply the 4 times the 3 and get 12, add the 2, and then divide by the 3. So you get 14/3. Now, how did that happen? Well, if you know that 4 2/3 is 4 plus 2/3, you can take the 4 over 1 and change the 4 over 1 to thirds by multiplying by 3 over 3. And I would get 12/3. So then I would have 12/3 plus 2/3. And when you add fractions, you add the numerators, and you certainly don't change the unit. Okay, now I could use number lines too. Let me do this quickly with the number line. So here I have 0, 1, 2, 3, 4, and 4 and 1/3, or 2/3. So, and now I'm going to change these into thirds. So I have 0/3 here. 1 is 3/3. 2 would be 6/3. 3 would be 9/3. 4 would be 12/3. And adding 2 more thirds would give me 14/3. All right, so pay attention to this one, because this one is going to show you why dividing is the same as multiplying by the reciprocal. So I'm going to take 4/5 and divide it by 2/3. So I'm going to change, this is the same thing as 4/5 divided by 2/3. So I'm going to change these into 15ths, because that's the LCM of thirds and fifths. So I'm going to get 12 15ths here, and I'm going to get 10 15ths here. So this is the same, right? These are the same number. These are the same number. So now I have 12 15ths divided by 10 15ths. Now the 15ths will cancel, and this will give me 12 over 10. So that is the answer. And now let's see how I can get this 12/10. I'm going to break this into factors. I could do this one as 4 times 3. And I could do this one, the bottom number, break it into factors, as 5 times 2. So 4 over 5 times 3 over 2 is going to give us 12 over 10. So let's look at our original problem right here. 4/5 divided by 2/3 is identical to 4/5 times 3/2. And I just showed you that has to be true. So I'm going to do one more of those. So I'm going to do 3/4 divided by 2/7. So I'm going to do it the same way. I am going to find a common denominator and cancel and get the answer. And then I'm going to show you that I could have gotten the same result if I would have just flipped or multiplied by the reciprocal. So I got to change this for a common denominator into 28ths. So 3/4 times 7/7 is 21/28. So this is 21/28 divided by 2/7 times 4/4 is 8/28. So this is 8/28. '28s cancel, and I get 21/8. That's the answer. Now I'm going to look, 21/8, I'm going to factor it. This will factor into 3 times 7, right? And this will factor into 4 times 2. So it could have taken 3/4 times 2/7 and gotten the same result. Because when we multiply straight across, right? So 3 times 7 is 21, 4 times 2 is 8. It's the same answer. I could have gotten it by doing this, which is over here. So that just shows you that dividing is the same as multiplying by the reciprocal. If I asked you something like this, it would be, you'd have a calculator. But what's important here is what they're asking and how to go about it, and what your answer is. So it says you have 12 ounces of water, costs $2.40. Determine the dollars per ounce and the ounces per dollar. So per means divide. And that's a division sign. So there's two different problems. First, I'm doing dollars per ounces. And then I'm doing ounces per dollars. And be really careful what you get here. Here you're going to put this in your calculator, or you can actually make this pennies. 240 divided by 12 would be 20, which is $0.2. So if you put it in your calculator, you get 0.2. But 0.2 what? Well, $0.2 per 1 ounce. This is sort of a preview of the next chapter. But it's also the division of units, how they divide. So this one here, you would put in your calculator 12 divided by 2.40, and you would get 5. But 5 what? And the answer is 5 ounces per $1. See, the denominator doesn't just disappear in these things. You have the units that divide, and you have to put numbers with them. I'm going to really concentrate on the units here, because that's the important thing. In order to get this, determine your salary for the week if you earn $13 per hour and work for 20 hours. So, dollars per hour means that. Now, I can either multiply these two, or I could divide, but let's see if I multiply dollars per hour, which I can put the 13 in here, times 20 hours. What am I going to get? Notice you can always put a number over 1. the hours cancel, just like a fraction. And I'm left with dollars. So if I multiply 13 times 20, I get $260. Because that's all I have left with the units. Okay, so here it says, how much time would it take a runner to complete a 100-yard race if they average 10 feet per second? So the equation distance equals the rate times the time. We're going to rearrange it for time. In other words, they want time as the output, so they want t equals. And then we could better utilize the distance and the rate. This is the rate, 10 feet per second, right? Per means divide. And let's pay special attention to the units. So I'm going to use the new equation to determine the amount of time the race took. So here's my original equation, distance equals rate times time. And I want to solve it for time, so I want t equals. So I'm going to divide both sides by r. R divided by r is 1. 1 times time is time. So time equals distance divided by rate. Now I'm just going to put the numbers in here, which this is 100. This is the way students do it. Some students, 100 divided by 10, and I get 10 seconds. Right? Is that correct? The answer is no. And that's not even going to make any sense if I look at the units. So I got 100 yards divided by 10 feet per second. Now I'm just going to look at the units. Yards divided by feet per second is the same thing as yards times seconds per foot. Right? How do you divide? You invert and multiply. So I invert it and multiply it. And this would be yards times seconds divided by feet. What does that mean? I have no idea. So what I'm going to do is I know there's 3 feet equals 1 yard. So therefore, 100 yards is 300 feet. So I'm going to use 300 feet. 300 feet. I'm going to put the numbers back into the equation here. Time equals 300 feet divided by 10 feet per 1 second, right? Now I'm going to look at my units here. I got feet divided by feet per second, which is the same thing as feet times seconds per foot. These cancel, and I get seconds. So the result of all this here is 30 seconds. A slow runner, but that's what the answer is. You might want to play this a couple times and refollow the logic here. Okay, so here's one. You have 3.5 cords of wood, right? Wood stacked up, whole bunch of it. And you need to move to your house. Each truckload holds 2/5 of a cord. How many truckloads will it take? Well, here's the first question I have for you. Is it going to be, the answer going to be more than 3.5 or less than 3.5? Think about that. Well, the answer is more than 3.5. Now, are you going to divide or are you going to multiply? And the answer is you're really ultimately here going to multiply. But you're going to start out dividing. You got 3.5 chords, and divide that into 2/5 of a chord per load. So let me just look at the units. I got 3.5 chords, and I got 2/5 of a chord per load. So if I wanted to go ahead and see what this is going to be, I could say chords divided by chords per load. That's the same thing as chords times loads per chord. And the chords will cancel and you got loads. So when you divide, you're going to wind up multiplying by the inverse, which is true with what's going on here. So let me take 3.5 and turn it into a fraction. So that would be 7/2 divided by 2/5. That's the same thing as 7/2 times 5/2, which is 35/4, because you multiply straight across, which is 8 3/4 of a load. In other words, it's going to take you 9 trips. You can't take 3/4 of a trip, right? How many truckloads would it take? It would take 9. So for number 6, which I'm going to do here, you can hold 3 gallons of water at a time. How many trips will it take to fill up a 12-gallon container? Again, I'm going to ask you, is the answer going to be greater than or less than 12? And if you answered greater than, you're right, because if you were carrying a gallon at a time, it would take you 12 trips. But you're carrying less than a gallon every time, 3/4 as a matter of fact. So it's going to take you more than 12 trips. So this is simply, you can do this 12 times 4/3, which is going to give you more than 12, or you can do 12 divided by 3/4, which, by the way, is the same thing as 12 times 4/3. So either one of these perspectives is correct. So this is going to be, I'm going to reduce first. 12 divided by 3 is 4, and 4 times 4 is 16. 12 divided by 3 is 4, and 4 times 3 is 16, right? So it's going to take you 16 trips. So here you have 5/8 of a gallon in your gas. That's how much you have. You have 5/8 of a gallon of gas. Your string trimmer uses 1/12 of a gallon of gas per hour. How many hours can you run the string trimmer? Well, you have 5/8, and you're going to divide it into 1/12, which is the same thing as 5/8 times 12/1. 12 divided, you can reduce this. You can always reduce, cross reduce. You can divide this by 2 and get, you can divide it by 4 and get 2. And divide this by 4 and get 3. So you get 15/2, which is 7 1/2 hours. Now let's just take a quick look at the units here. You have gallons, and you have gallons per hour. And let's look at what happens here. Gallons divided by gallons per hour is the same thing as gallons times hours over gallons, right? Division is the same thing as multiplying by the inverse. Gallons cancel and you get hours. So that's how you can figure that out. So these are tricky. There's a lot of ways to do it. So this is problem 11 in the homework, and it's the last one. And you're given the units and the numbers. They're going to determine the output and what the output means. The units is what it means, right? Like 5, what's 5? 5 clouds, $5. 5 what? 5 pennies? 5 dimes? So the output's important, right? So you can look at this and say, okay, these cross out. So the answer in units is miles. And 50 times 3 is 150. So 50 miles per hour times 3 hours is 150 miles. This one here, it's a conversion. 5 divided by 5, or Celsius divided by Celsius, because this is over 1. It's always in the numerator unless it's expressed differently. Cancel. So I'm left with Fahrenheit. Also, the 5's cancel. So I'm left with 9 plus 41 for the numbers. 9 plus 41, 32 is 41. 41 what? Degrees Fahrenheit. Take a close look at those.